In 1964, two Aerobee suborbital rockets were launched with the goal of mapping X-ray sources in the sky. Each rocket contained a directed Geiger counter so that as the rocket rotated at the peak of its trajectory to measure the direction of X-ray sources. Today we will discuss with you about the very first black hole of the universe. Welcome back to Signatures Life and you're watching Signatures Science. The project discovered 8 X-ray sources, including a particularly bright one in the constellation Cygnus. As X-ray telescopes became more precise, it was clear that Cygnus X1 wasn't connected to bright optical source. The X-rays were quite bright and came from a region almost star-like in size. This suggested that it could be a stellar mass black hole. The idea was so controversial that it inspired a bet between Stephen Hawking and Kip Thorne in 1974, with Hawking betting against the idea. By the 1990s, it was clear Cygnus X1 could only be a black hole, and Hawking conceded the wager. Over the years, Cygnus X1 has become one of the most studied objects in the sky. We now know that it is an X-ray binary, where the black hole closely orbits a blue supergiant star known as HDE 226868. The two orbit each other so closely that material from the star is captured by the black hole. As the stellar material becomes superheated in the accretion disk of the black hole, it emits the powerful X-rays we first detected. But there is still a great deal we don't know about Cygnus X1, and one of the most basic is its distance. We have known that Cygnus X1 is a few thousand light years away, but pinning down the exact distance is a challenge. The distance of nearby celestial objects is typically measured using parallax, where the apparent position of the object is measured relative to more distant objects. X-ray sources are difficult to pinpoint, so this method isn't effective for X-ray objects. Cygnus X1 also emits radio light, so you could use radio observations to measure its parallax, but that also isn't very precise. But a new study uses a couple of tricks to get an accurate distance measurement. Rather than using a single radio antenna to measure parallax, the team used the Very Long Baseline Array, otherwise the VLBA, which has 10 antenna dishes scattered across the United States. Together they create an America-sized virtual telescope which gives you greater precision. But the team also measured the motion of the black hole and its stellar companion. This lets them measure the distance between them. Combining this with VLBA parallax observations, the team calculated that Cygnus X1 is about 7,000 light years away. This is a greater distance than we had thought. Since our estimation of the black hole's mass is based on our distance measure, this also means the black hole is more massive than we thought. The team calculated its mass to be 21 times that of the Sun, which is 50% larger than previous estimates. Cygnus X1 isn't the closest black hole to Earth, but with its proximity and bright X-rays, it will continue to be the most studied local black hole, and as this latest research shows, we still have much to learn.